Hello, my amazing students. This is Mrs. A, and I'm here to bring you 5.4 on my lunch break. So let's see how far we get. Okay, so we're starting at the problems at the back of the PowerPoint, and the first one is natural log of 6x. Now what we're doing in this lesson is this one is all about the properties of logarithms, and remember there are three big properties and we're going to use one of them here. So basically the one we're going to use right here is the product property. So we're going to take the natural log of mn is equal to the natural log of m plus the natural log of n. So anytime we have a product, this is the property. You could use log or natural log. Anytime I have a log of a product, it's going to break up into the log of the first plus the log of the second part of the factors there. So here we've got 6 times x is the argument, so we're able to break this up accordingly into natural log of 6 plus natural log of x. Okay, now that is the exact answer, and we always want to have exact answers unless we are told specifically to approximate. So that's the end of that one. There's nothing more that we have to do because the only thing we could do is go to the calculator and get an approximation for what natural log of 6 is, but we can't do anything with the natural log of x. We're done with that one. Okay, so the other one, number 2, that is dealing with the same concept is the log base 4 of a product. So we're going to break this one up into log base 4 of 64 plus log base 4 of 16. Okay, now remember, the log is the exponent to which you raise the base to get the argument. So we know that 64 is 4 cubed. So log base 4 of 64 is 3, and 4 has to be squared to get a 16, so the exponent is 2. So this is a plus 2, and the answer to this one should be 5. That one was fully able to be evaluated. In my answers, they didn't even go that far. They just left the answer like this. So I would have gone ahead and done both of them, but because this is the exact answer, isn't it? It's able to be fully evaluated. Okay, so the next thing that we're doing, I've got a tickle in my throat, sorry about that, is we have log base c of k to the negative 5. And now we're going to use the product rule, which basically says that when we have a logarithm and we have the argument is raised to a power, that becomes, we're able to take the power on the argument, okay, over here to the front. And this is really a extension of the product rule, because basically I could write this as 1 over k to the 5th, which would be the same thing as 1 over k times 1 over k times 1 over k times 1 over k times 1 over k. And then I could treat it as a product, which means I could add the logs together, which would end up being the 5 times the log. Okay, but I'm going to go ahead and use this method, which is the power rule for exponents. And the power rule basically says that if I have log base b of n to the, we'll let this be x, okay, then this x can run around to the front equals x times log base b of n. Okay, so that is our power rule. And in this one, we're going to run this negative 5 around to the front, and we're going to get negative 5 times the log base c of k. And since we can't do anything with the c and the k, that is our final answer there. And that's exactly what they have. Okay, so the next one that we're going to do is number 4, and it says log base 4 of square root of y. Okay, so log base 4 of square root of y can be done with the power rule, because we know that square root of y is the same thing as y to the 1/2 power. So we have log base 4 of y to the 1/2 power. So now that we have our argument here expressed as something to the power, then we can take our 1/2 and run it around here by the product rule, the power rule, and we get 1/2 log base 4 of y. And that should be our final answer, and it is. So we can't do anything with simplifying it any further. Okay, so the next thing that we're doing is we're going to talk about the quotient rule. So we've got log base b of 4 over w. Okay, so this is our, right here, this is the argument of the log. So when we have a quotient that appears in the argument of the log, we can apply the quotient rule, and that's going to be log base b of 4 minus, which makes sense, when we had the product we used a plus in between, minus log base 4 of w. And since we can't do anything further with that, that is our final answer for number 5. Okay, and we'll come back with more. All right, so now we have a problem, number 5, in the back of the PowerPoint. And we are to express this as a difference of logarithms. And so we have the log of the quotient. And our rule is, when we have log base b of m over n, it will be the same thing as log base b of m minus log base b of n. Okay, so that's the rule right there, that we just subtract the two logarithms. So here, this one is going to be just log base b of g minus log base b, no, it's an a, sorry, I'm getting my definition mixed up with the actual problem. That should be a base a of l. Okay, so that should be your answer, and it is. And that's really all there is to that. Okay, so let's look at number 6. Sorry, this one is number 7. That one was number 5. I misnumbered it. This one is number 7 in your PowerPoint slides. And so now we're to write this as a combination of sums and differences of logarithms. So we have product, product, product. Everything's a product, but we're going to have some powers in here too that we can run around. So the first thing I'm going to do is break this up as this times this times this. Okay, so I'm going to break it up that way first. So I'm going to have log base a of x squared plus log base a of y plus log base a of z to the 6th. Okay, so that was applying my product rule. So now I'm going to apply my power rule and simplify these that have the square. Okay, so this is going to run around to the front, and I'm going to have 2 log base a of x, because the exponent runs around according to the product rule, and then plus, this one does not change, it's just going to be log base a of y, and then the last one is going to, the 6 of power 6 is going to run around to the front, so we're going to have 6 times the log base a of z. Okay, hopefully you can read that. So that should be our answer. And I'm going to read it from the screen just to make sure I didn't make any mistakes. Twice log base a of x plus log base a of y plus 6 times log base a of z. And I think that is what I have up there. That is the answer to number 7. Yep, that's what I had. So now we're going to move on to number 8 here. And again, we're going to write this as this product. The argument here is a product, so we're going to write it as the sum of the logs. So we're going to have log base A of 2 plus log base A of x to the 5th plus log base A of y plus, I'm going to have to go downstairs, log, I'm going to do the 2 in a minute, we'll come back and do that, log base A of z squared. Okay, so I did the first step and I wrote the product, that is the argument, into the sum of the individual logs. Okay, so now I'm going to take anything that has an exponent, which should be right here with the x to the 5th, and instead of rewriting that whole thing, I'm going to run it around to the front. But first, let me let you see this step, get that one down, and then I will show you the last little bit here that we need to do to finish it up. So now we're going to take this 5 here, and it's going to come, according to the product rule, right down there and sit in front. I'm going to squeeze it in because I don't want to rewrite the whole thing. And then this square is going to come right around here and become a 2. And those were the only ones that had exponents. So that should be the correct answer. So I'm going to read it to you from my answer screen. So log base A of 2 plus 5 times log base A of x plus log base A of y plus 2 times log base A of z. Okay, and I hope that is what I actually have there. And I'm checking it just to make sure I don't leave any errors. And it is correct. So it's not very neat, but it is correct. Okay, so just so that you have a good view of that. So this was problem number 7, and this was problem number 7's answer. Problem number 8. Problem number 8's answer, so that you can maybe copy them a little bit neater on your problem. Okay, so problems and answers. So here we have problem number 9, and they're doing a lot of using the variables because they want you to get the properties and not worry so much about the numbers that are going on here. So this one we're supposed to write as a single logarithm, and notice that we have a log base b of t and a log base b of s, so they both have the same base, but we should not have this 5 here when we're going to go backwards and write it as a single log. So I'm going to take the 5 and I'm going to run it back up as an exponent. So it's going to cancel here and run back up over there to be a t to the 5th. And now I just have log base b of something minus log base b of something. So I can write that as 1 log of a quotient because there's a minus in there. We're going to have log base b of t to the 5 divided by s. And this, again, is the whole argument there. And that is the correct answer, according to the book. And then this one is number 10. Okay, and again, we are to write this as 1 logarithm. So I have an exponent that's going to, a coefficient that's going to run back around and be an exponent, and then a coefficient that's going to run back around and be an exponent, because I always want log of this plus log of that. So this one is going to be a product when we finish because it's a sum in the middle. The last one was a quotient. So we're going to just take this 1/2 and we're going to raise the s to the 1/2 power. We're going to take this 5 off and raise the m to the 5. Okay, so now I have log of this plus log of that. And since I have it in that form and they are the same base, then I may say log of the product. So I'm going to end up with log of the product, and it's going to be s to the 1/2 times m to the 5th. Okay, and that little times dot is just there for clarification. It really doesn't have to be there at all. Okay, now what they did is they took this same answer and they went one further, and in my book it would not necessarily be preferred, but I want you to be able to recognize it. This s to the 1/2 they turned back into a radical. So their answer is log of m to the 5 onto the square root of s. And that's what they have in the answer key. And certainly you should recognize that as an answer. And if I told you to put it into radical form, you should be able to do it. If I didn't tell you to do it a specific way, then I should expect to accept both of those answers because they mean the same thing. Okay, so that is the way you do those problems, and we have some more here. So here we have number 11, and on the back of your PowerPoints, and I just dropped my marker. So this one's just a little bit more complicated, and again, we're supposed to write this as one logarithmic expression. So the very first thing we want to do is make sure that it is log base b, log base b. And this one's good, but this one has a 2 out front. So what we're going to do is we're going to take the 2 that's out front, we're going to bring it around here, and it's going to actually square the square root there. So we're going to take that 2, we're going to mark it off here, and it's going to come up here and square the square root. Okay, and then when we write it, now we have log base b of x to the 7 minus log base b of the square root of x squared, which is just going to end up being x. So now that it's a log base b minus a log base b, we can turn around and write it as a quotient. So we'll have log base b of x to the 7 over the square root of x squared, which is x. Okay, and now can we simplify that further? Okay, so now that we have it in this form, can we write that as log base b of x to the 7 divided by x is x to the 6th? Okay, so this would be written as one logarithm there. Okay, now that we have it in that form, an equivalent logarithm would be 6 times log base b of x. Those would both be single logarithm forms that you could use. Okay, so that one was number 11, and that is the correct answer. Okay, number 12, boy, it looks complicated because you got this whole shebang here, and number 12 almost doesn't look right because you have this y plus y down here. And we know that when we have a product that we can split it up into the sum of logs, but we can't do anything with a log of a sum. Okay, we can write a log of a product as a sum, but we have no way of simplifying that. So that should wind up being in our answer because it is not going to simplify. But this up here, we're going to be able to do something about it. So what we're going to do is this 2/3 is actually, this is where the parenthesis closes, right here. And I don't have that in there. So I'm going to close this parenthesis off so the problem is written correctly, because the 2/3 is only applying to this here. So now, right now, don't I have this all written as natural log of something minus natural log of something? So since that inside those brackets is in a good form, I'm going to go ahead and use my backwards of the quotient rule, okay, because the quotient rule says that they separate into the difference. So now I'm using the going backwards on that. So I'm going to take this inside. I'm going to keep the 2/3 outside right now. I'm not going to mess with that. And then I'm going to get the natural log because they're both natural logs, and since there's a minus, it's going to be y squared minus 64 on the top divided by y plus 8 on the bottom. And this is one big radical. I don't need to put not radical parenthesis. So then I can just close off that and put plus natural log of y plus y. Now, it would be okay to put natural log of 2y, but I can't simplify it any further than that. I can't change its form. So now, look at what's happening in here. What is y squared minus 64? That's going to factor into conjugate. So we're going to end up with y plus 8, y minus 8 over y plus 8. So these are going to cancel there, okay? And so I'm going to end up with natural log of y minus 8. And then I've got the 2/3 out front, which can turn around and become an exponent, okay? So I almost need to get a second board for that, and this is what I'm going to do. Okay, so I was running out of room, and I got a second board. So this is what I had before. So natural log of y minus 8, all of that multiplied to the 2/3, and then I've got this natural log of y plus y. Over here, I've done the simplification of that by canceling out the y plus 8s. And so this is as simple as I can get it, but now I'm going to take the 2/3 and run it around up here. So I'm going to cancel it off here and put it as an exponent here. So 2/3 right there. Okay, and so now I've got a natural log of something plus a natural log of something. And that power can just stay tucked in there with that argument. So now I've got the natural log. Since it's a plus in between, I can say the natural log of y minus 8 to the 2/3 times y plus y. Okay, now I'm going to go one step further than the book does. I'm going to go ahead and make this 2y because that's perfectly fine. It looks a little awkward to have y plus y when 2y is a little bit more simplified there. But that's all I can do to it. So the book's answer was natural log of y minus 8 raised to the 2/3 times the y plus y. But I just put in a 2y instead of the y plus y, and both are correct. Okay, so that was number 12. And number 13 here is one of those where we cannot use the calculator other than to add and subtract, multiply, or divide, because they're giving us a log that has no base. It's a base b. We can't calculate that. Our change of base formula does no good for us. So what we're trying to do here is we're trying to evaluate log base b of a times b. So these are problems that are designed to check your knowledge of the properties. So basically, wouldn't log base b of a times b be log base b of a plus log base b of b? Okay, but then they've given me that log base a b of a is 1.186, and they've given me that log base b of b is 0.332. And so all I have to do is add those together, and I should wind up with 1.518. 1.518 should be what happens when I take 1.186 and add it to a 0.332, and that looks like that is correct. Now remember, when you're adding decimals, you must line up the decimal points, always. Okay, but that looks good to me. And that one is the correct answer for number 13. So now we're looking at number 14, which looks very similar, but it's like this. And this one has a quotient because 1 over 21 is a quotient. So we're going to take 1 over 21 and we're going to say, well, that would be a log base a of 1 minus log base a of 21. But I am not to where I need to be because they didn't give me a log base a of 21, they gave me a log base a of 3 and a log base a of 7. So now what I need to do is I need to take this right here, the log base a of 21, and write it instead of 21 as a 3 times a 7. So I'm going to take the 21 out and I'm going to do 3 times 7, which then means that I can use my product rule. So I'm going to end up with log base a of 1 minus parentheses. So let me see if I can squeeze this. Log base, now I'm going to get a new board here. Okay, so this is what I had, and I'm going to erase that because I was just getting down to where there was no room. So we had log base a of 1, and I have on the new board, I have log base a of 1. But then I took my minus log base a of 3 times 7, and now I'm going to split that up. But look at what I did. I took the minus and stuck it outside of a bracket, and then I put the log base a of 3 plus the log base a of 7 because I started with a log base a of 21. I have to be very, very careful to make this minus right here distribute through the whole sum here. So I changed the product into a sum, and that minus sign that is following this term must go through the whole thing. So always use brackets when you turn your product into a sum. Okay, so now that I've got that, let's go ahead and distribute the minus sign. We got log base a of 1 minus, and then log base a of 3, and then the minus distributes, so we get minus log base a of 7. Now they've given us this one, and they've given us this one, okay, because that was in our initial problem. So I'll write those on the board. What do we know about log base a of 1? This is one of our properties, right? Anytime we graph the logarithm, doesn't it go through a very special anchor point? And that point is 1, 0. So the log, any base of 1 is 0. So this whole thing is going to just go 0. Okay? So then I'm going to put a negative in front of what they gave me. So they gave me a log base a of 3 is 1.099. So I'm going to put here, right underneath here, a negative 1.099. And then they give me a log base a of 7, which is 1.946. So I'm going to do minus 1.946. So basically, I am going to subtract those two, but it's the same thing as adding them together and taking the minus sign. Okay, so our answer for that one should be negative 3.045, which should be what you get when you add those two negative numbers together, since they go in the same direction. Okay, so the last problem here is moving into more properties of logs. Okay, so now in the first one, we have a base of 5. And the base of 5 is being raised to the logarithm base 5. Remember that the log is the exponent to which you raise the base to get the argument. Well, you just raise the base 5 to the log base 5, and you will get the argument. Okay, so your rule that we're following is log is a raised to the log base a of x is x. So this is the principle that we're going to use. The base raised to the log base, same base, is always going to give you the argument because that's the definition of the logarithm. The log is the exponent to which you raise the base to get the argument. We just raised the base to that log exponent, therefore we get the argument of the log. Same thing is true here. We have a log, but we have, since there's no base, it is log base 10. So we have a 10 raised to a log base 10, which is going to just give us t. Okay, so the answers were 3x and t on that one. And we are done with 5.4. And we need to do 2 more before you're ready for your test. So I'm going to press forward and do 5.5 and 5.6 for you today. And this is Mrs. A, and may God bless your day.